Okay, now we will do some problems based on the linear transformation. Okay, linear transformation. First we will do this problem. First we will do this problem. T be a linear mapping. T be a linear transformation defined by, right, let T r to the power 4 to r to the power cube. Okay, r to the power 4 to r to the power cube be a linear transformation. Be a linear transformation be a linear transformation defined by, right, defined by this formula: T of x1, x2, x3, s4 on the matrix of the form x1, 2x2, 3x3 minus x4. 3x1, 5x2, 8x3 minus 2x4. x1, x2, 2x3. There are three parts here. First part, they asked to prove that find a matrix A such that Tx equal Ax. Find a matrix A such that T of x equal Ax. Okay, T of x equal Ax. Second part, they asked to find the basis for a null space of T. Second part, find a basis for a null space of T. Of T. Third part, find the rank. Find the rank. Right. Find the rank of the linear transformation T. Of the linear transformation T. There are three questions. You want to solve it. Okay. T be a linear transformation r to the power 4 to r to the power cube. Okay. Be a linear transformation. First question, they asked to find a matrix A such that T of x equal Ax. Here is your representation matrix, no? Therefore, you want to find the representation matrix first. Here, your polynomial, here r power 4 and r power cube. R power 4 and r power cube, you can use the basis for this one as a standard order basis for R4, and you can use the standard order basis for R cube. Okay. Okay. Right. Now we will do okay. Now you can use here R power 4. You can use this your the standard order basis. You can use it, right? Let E1, E2, E3 and E4, right? E4 be the standard 4-dimensional unit basis vectors for R4. Be the okay, be the standard 4-dimensional okay, 4-dimensional unit basis vector for R4. That means you already know that this R4, this your basis of the form 1 what else 0 0 0 0 1 0 0 0 0 1 0 0 0 0 1. These are the basis for the R power 4. For a R cube basis here, gamma, you can identify by gamma 1 0 0 0 1 0 0 0 1. These are the order basis beta for the R power 4. This order basis beta gamma for R power cube. Okay, these bases are used here. Okay, the representation matrix. Now we want to find the matrix A. No, that is matrix A is a representation matrix. No, representation matrix. Now we will find the representation matrix first. Okay, right. How we can find the representation matrix? We use this basis. Okay, we use this basis. Very important, because we mentioned here we use the standard order basis, right? First you find this value. First E1, no, E1 means like this. You can put like this. Okay, 1 0 0 0. Okay, or what is the value of this matrix? Then you can write these values here. Only x1 1. Here you can put here x1 1, others are 0, x1 1, others are 0, x1 1, others are 0. That means 1 3 1. Now you want to write this one, right? Here for a R cube, your basis of the form gamma. No? I already told you here. R cube, the standard order basis becomes 1 0 0 0 1 0 0 0 1. We can write these values equal to 1 times 1 0 0, 3 times 0 1 0, 1 times 0 0 1. It is the idea, right, to find the representation matrix. Next one, T of, next, what is the unit standard order basis for this R4? 0 1 0 0. What is the value you get here? Here only S2 0, S2 1. S2 1 means 2 5 1. Then you can write 2 times here R cube standard order basis here 1 0 0, 5 times 0 1 0, 1 times 0 0 1. But next 0 0 1 0. So what is this one? Here only x3 1. X3 1 means 3, 8, 2. Then you can write 3 times 1 0 0, 8 times 0 1 0, 2 times 0 0 1. Next 0 0 0 1. For this case only x4 1. Here x4 terms -1 -2 0. Now you can write the representation matrix A, right? You found the all values there, then you can easily find the representation matrix. Okay, now your A is now your this each one you can draw represented by right T of you can put here beta is order basis for R cube is gamma is order basis for beta is order basis for R4 R to the power 4, gamma is order basis for R power cube. This one equal to your A represent matrix A. This is of the form, it is of the form here you can write this values in the column wise 1 3 1 no 1 3 1. Therefore 1 3 1 you won't write column wise here like this 1 3 1. Here 2 5 1 you won't write column wise 2 5 1 2 5 1. Here 3 8 2 you won't write column wise 3 8 1. Here -1 -2 0 you won't write column wise -1 -2 0. It is the representation matrix, right? Now we finished the first question. Second part, find a basis for a null space of A, null space of T. Okay, null space of T. How can you find the basis for a null space of T? You already know that. Suppose, right? Right. You already know that null space means kernel, no? Yeah. You know that. Suppose this T of x equal to 0, then this x belong to kernel of T, no? T of x equal to T of x equal to 0, then x belong to kernel of T. You already studied, right? Now you have the formula T of x equal to, right here, T of x. Now you have the formula here T of x equal to 0 means x belong to kernel of T. Now they define T of x equal to Ax. Therefore T of x 0, no? Therefore Ax 0. Therefore x belong to, for this case also x belong to kernel of T. Now you want to consider this condition Ax equal to 0, then you want to find the x values. For this part, using a system of linear equation, you already know that Ax equal to 0 case, how can you find the these x values, right? Right. First, you put the augmented form for this part like this. Your b values also all are 0. No, b values all are 0. Okay, right. Now your a value is this one. You put like this 0, 0, 0. Your a value is this one 1, 3, 1, 2, 5, 1, 3, minus 1, 8, minus 2, 1, 0. Now we want to do some row operation. Then you want to find the row reduced echelon form. From this row reduced echelon form, you can find the values of which values? This x1, x2, x3. Yeah, s1, s2, s3, s4. Okay, right. From that one, you can find the basis, right? From the system of linear equation, you have some ideas, right? How can you find the basis, right? Now we do the row operation. R2 replaced by R2 minus 3 times R1 and R3 replaced by R3 minus 1 times R1. Then you get 1, 2, 3, minus 1, 0. Here 0, minus 3, minus 3. Here minus 3 means minus 6, 5, minus 1. Minus 9, 8, minus 1. 3 minus 2, 1, 0. Here I will here multiply by here minus 1 at here minus 1 plus 1 0 minus 2 plus 1 minus 1 minus 3 plus minus 3 plus 1 minus 2, no, sorry here mistake 382, sorry 382, here 2. Now therefore here minus 3, 2 becomes minus 1. Here 1, 0 becomes 1. Here 0. Therefore it is both rows are the identical. Therefore you get this row become a 0. R3 replaced by minus 1 times minus R2. Then you get 1, 2, 3, minus 1, 0, 0, minus 1, minus 1, 1, 0, 0, 0, 0, 0, 0. Okay. We want to get a row reduced echelon form. Therefore, for row reduced echelon form, you want to get here 1, here 0, no? Right. Now, now R2 replaced by minus 1 times R2. Then you can get here 1 value 1. Now I already mentioned we want to get the row reduced echelon form. Here we leading entry 1. Okay. For second row this leading entry 1. Therefore we want to get here 0. There's no leading entry, no problem. Therefore it is a for row reduced echelon form you want to get here 0 value. R1 replace r1 minus 2 times r2. 1, 2, 3 minus 1, 0, 0, sorry, here 0, no? Here 0, sorry, here 0, minus 2, 3, 1, 2, 1 means 1. Okay, here 1, 1, minus 1, 0, 0, 0, 0, 0, here 0. It is the row reduced echelon form. Okay, it is a row reduced echelon form. Therefore, from this one you can find the values of x, y, z. No, sorry, x1, s2, s3, s4. Okay, right. From this part you can write 1, 0, 1, 1, 0, 1, 1 minus 1, 0, 0, 0, 0. Here x1, x2, x3, x4, 0, 0, 0, 0. Here are 3 zeros, sorry. Okay. Now from this one you can write x1 plus x3 plus x4 0 and x1 plus x2 and minus x3 0. Then you can get two equation x1 x1 plus x3 plus x4 equals 0, x2 plus x3 minus x4 equals 0. You want to find x, no? x1, x2, x3, x4. Right. Now you can write x1 in terms of x3, x4, s2 in terms of x3, x4. Therefore, you take the parameter x3 and s4. Therefore, you put x3 as one of the parameter t1, s4 as one of the parameter t2. Then you get before that you can write let x3 equal t1, s4 equal to t2. There are two parameters. Now you can write here s1 equal minus s3 minus x4 minus t1 minus t2. s2 equal s4. s4 means t2 minus t1. s3 t1, s4 t2. Suppose you take t1 outside, you get minus 1, minus 1, 1, 0. t2 outside, you get minus 1, 1, 0, 1. Okay. T1, T2 belong to real. Therefore, these two are the basis for the system AX equal to 0. Okay, AX equal to 0. You already know that AX equal to 0 means X belongs to kernel of T. Therefore, these are the basis for a kernel of T. Right? These are the basis for a kernel of T. The kernel of T means null T, no? Yeah. Kernel of null T basis are these are the null T basis. Null T, right? Null T basis, no? Null T. They ask the question, find a basis for a null space of T. Okay. For null T, right? Your basis is both your basis, right? For null T. null t, right? Uh, these are the bases. Minus 1, minus 1, 1, 0, minus 1, 1, 0, 1. These are the bases. Span condition satisfying. It is linearly independent, right? The upper basis. Therefore, it's null of t, no? Null t. Okay, null t. Some books null t they are denoted by n of t. Okay, some books null t they are denoted by nt, n capital nt. Okay, for a C part, you want to find the rank of the linear transformation T. For that, using the rank nullity theorem, by using rank nullity theorem, here what is the dimension of null of T? Null of T means kernel of T. What is the dimension of null of T? 2, no? There are two bases linear independent, therefore dimension is 2. You have the formula for the rank nullity theorem. This rank of T, right? Nullity of T equal rank of T, nullity of T equal here. What is the dimension for R power 4, no? In U, yeah. Therefore it is 4. R power 4, no? It's 4. It's a B, that value is B, that dimension 4. Now nullity of T, right? Nullity of T means, right, dimension of kernel of T, here 2, no? Therefore rank of T plus 2 equal 4. Therefore your rank of T means 2. Therefore your rank of T means 2. Okay, rank of T is 2. Nullity of T means dimension of nullity of T, right? Nullity of T means this nullity of T means dimension of kernel of T, right? Here dimension of kernel of T equal to dimension of null of T, that's 2. Understand? Dimension of kernel of T means dimension of null of T, that one 2. Therefore this one 2. Therefore rank of T is 2. Okay. Okay, now we will do this question. This exercise, let B be a vector space of 2 cross 2 matrix with real entries and P3 the vector space of real polynomials, and P3 is the vector space of real polynomial of real polynomials of degree 3 or less, of degree 3 or less than 3. Define the linear transformation T V2 P3 real by of the form T of, here you consider B. B be the vector space of 2 cross 2 matrix, no? You put here matrix. Your entries here A, B, C, D equal 2A, you get here P3 polynomial 2A B minus dx minus A plus C x squared plus A plus B minus C minus D is cube. Find the rank and nullity of T. Find the rank and nullity of T. Okay. Okay. Here your beta, it is here also very important. Use the beta, order basis beta for a 2 plus 2 matrix, no? 1 0 0 0 0 1 0 0 0 1 0 0 0 0 0 1. It is the beta for order basis beta for this B. Now gamma, this order basis for a P, what P3 real number 1 x s squared s cube. First we want to find the representation matrix. That is your first claim. You want to find the representation matrix first. T of, first you find the representation matrix. T of 1 0 0 0. What is the value you get here? Only A is 1. Therefore here 0, you get 2. Here A is 1, therefore minus S squared, minus S squared minus S cube, no, plus S cube. This one you can write 2 times 1 plus minus 1 times S, sorry, 0 times X, there is no X term, 0 times X minus 1 times S squared 1 times S cube. T of 0 1 0 0. This one you can write here. Your B is 1, there is no terms here. B is 1 means X, there is no term. B is 0, here B is 1, therefore X plus S cube, there is constant term, therefore 0 times 1, 0 times, sorry, 1 for coefficients of X 1, X into 1 into X, 0 times S squared 1 times S cube. T of C value 1, there is no C, 0 0 C1 minus S squared, C1 minus S cube, minus S squared minus S cube. Therefore you write, there is constant term, there is no constant term. 0 into 1, 0 into X plus minus 1 into S squared plus minus 1 into S cube. Only D term 1. 0, here 1 means minus X, here 0, 1 means minus X minus S cube. Then you can write 0 into 1 plus minus 1 into X, 0 into X squared minus 1 into X cube. Okay, now you can write the representation matrix here. Your representation matrix of the form T, your order basis beta, order basis gamma, it is equal to your A. You can write this column wise, these vectors here, elements here, 2 0 minus 1 1, 2 0 minus 1 1, here 0 1 0 1, 0 1 0 1. Okay, here 0 0 minus 1 minus 1, 0 0 minus 1 minus 1, here 0 minus 1 0 minus 1. It is your representation matrix. Okay, it is your representation matrix. From the representation matrix you can find the rank of T, no? It is a representation matrix T, that means A, T of beta gamma. From this representation matrix you can find the rank. The representation matrix rank and equal to the transformation mapping T rank also, no? Yeah. Now you want to find the rank for this matrix. For rank of T. Okay. For rank of T. Two, zero, 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 one, zero, minus one, minus one, zero, minus one, zero, one, one, minus one, minus one. First, we indicate the rows R4 and R1. Now R3 replace R3 plus R1, R4 replace R4 minus 2 times R1. Then you get here 0, here multiplied by 1, no? Therefore here 1. This one, here minus 1, here minus 1, minus 2, here minus 1, here minus 2 plus 2, 0. Therefore minus 2, 2, 2. Now R3 replace, it is your leading end, therefore others are 0. Now for second row, this is your leading end, therefore you want to get here both are 0. R3 replaced by R3 replaced by R3 minus R2, and R4 replaced by R4 minus plus 2R2. 1, 1, minus 1, minus 1, 0, 1, 0, minus 1, 0, 0, minus 2, 1, minus 1, 0, 0, 0, 2, minus 2 plus 2, 0. Now it is your first leading end, the others are 0. Here for second row leading end hit this one, others are 0. The third row non-zero leading end here, therefore you want to get here 0 value. R3, R4 replaced by R4 plus R3. Then you get 1, 1, minus 1, minus 1, 0, 1, 0, minus 1, 0, 0, minus 2, 0, at both 0, 0, 0, 0. Therefore, it is your leading any other this one 0. Therefore, it is a equivalent form. Therefore, rank is 3. Non-zero in rows 3. Therefore, rank is 3. right? Therefore rank is 3. Rank of T is 3. Okay. Therefore there are 3 linear independent non-zero rows. Therefore rank of, right, rank of T is 3. Now they asked to find the nullity of T. Then we use the, for that part we use the rank nullity theorem, right? By using rank nullity theorem, here for dimension of B, right? What is the dimension of B? Dimension of B is equal to 4, no? Yeah. The dimension of B equal to 4, right? Dimension B equal to M2 cross 2 matrix, no? That rank is 4. Dimension of B is 4. First you write the formula. Dimension of B equal rank of T plus nullity. Here dimension B 4, rank of T we already found 3, nullity. Therefore nullity 1. Nullity means dimension of kernel of T equal to 1. Now we move to the next question. Let A be an M cross N matrix. The null space of A is denoted by null space of A is denoted by null of T, null of A. The dimension of the null space dimension of the null space of A is called as a null of A. Null A. Now prove that first condition, this null of A, null of A, null space of A is null of A equal null of A transform A. Second part, rank of A transform A. These two parts you want to prove it. First part, let you take one of the element explained in the null space, right? Null of A. Then Ax equal to 0, no? Null of A means kernel of A. Kernel of means T of, suppose X belongs to kernel of T means, then you can write T of X 0. No? T of X 0. Therefore, kernel of T is null of T. Therefore, Ax 0. Now to take both sides A transform, this one A transform Ax equal to 0. So implies this X belongs to now null of A transform A. Okay, null of A transform A. Therefore, null of A subset of, right, subset of null of A transform A. It is first. Null of A transform A. It is first. Now let X belong to null of A transform A. Then you get A transform Ax equals 0. Right? A transform Ax equals 0. Now you multiply both sides X transform A transform Ax. This one you can write Ax transform Ax, this one 0. You know that this Ax transform Ax means this norm of Ax. The property is there, this one 0. Our norm of Ax 0 means you have some norm properties Ax 0 in the product space. Right. Ax 0. Suppose Ax 0 means this X belong to null of A. Okay. we take x belong to null of A transform A. Now we prove x belong to null of A. Therefore, null of A transform A, null of A. It is second one. From both, you will get null of A equal null of A transform A. Okay, null of A transform A. B part, second part, using the rank nullity theorem, by using rank nullity theorem, this rank of A equal, right, here A be an n cross n matrix, no? Therefore, rank of A n minus dimension of null of T, null of A. This one you can write n minus, right, dimension of, we already proved, null of A equal null of A transform A. This one equal, here rank of A equal to n minus dimension of null of A, no? Therefore, this n minus dimension of null of A transform A. Therefore, this is the rank of A transform A. That is, rank of A equal rank of A transform A. Using the rank nullity theorem, rank of A equal n minus, right? Here n is the n cross n matrix. Therefore, n minus dimension of null of A. Therefore, n minus dimension of null of A, we already proved dimension of null of A equal null of A transform A. This n of minus dimension of null of A transform equal to rank of this A transform A, and you get this formula. Now, Okay, now we will do this problem. This exercise, let T be a mapping E cube like R cube, and L be another mapping E squared to E squared B, right? B defined by B defined by right B defined by right B defined by T of x1 x2 equal x1 x1 plus x2 x2. Here this T is a mapping from R to E squared, no, E squared to E cube, 3 coordinate, 2 coordinates, and L is a mapping, right? L is a mapping, L is a mapping L is a mapping here L is a mapping R, here you can change here, L is a mapping R, sorry, E squared to E cube, E squared to E cube, L of x1 x2 x3, x1 minus x2 x2 minus x3. Okay, here E cube, sorry, here E cube L, here E squared. Is it okay? Right. First question, calculate is L composition T of x1 x2 so that so that L composition T is linear transformation. Third part, determine the standard matrix determine the standard matrix matrices for L and T and L composition T. That means you want to find the representation matrix. Determine the standard matrix means representation matrix. You want to find it for this part. Standard matrix for L and T and L composition T. Part number 4. So that the matrix of L composition T, that means the representation matrix of the L composition T is the is the representation matrix of the L composition T is the product of the matrix of L and matrix of T. Product of the of matrix of L and the matrix of T. First, you want to calculate the L composition T x1 x2 value. First part, L composition T x1 x2 value. So you can write L of T of x1 x2, but you already know that T of x1 x2 values becomes x1 s1 plus x2 comma s2, x1 s1 plus s2 comma s2. Now for this, what is the value of this part? Your x1 minus x2, no, therefore x1 minus x1 minus x2, and you want to add h2 and h3. You want to add this both, x1 plus x2 plus x2. So here minus, no? Yeah, here minus. Therefore here minus. Now minus x2 plus x1. It is your matrix L composition T function. Okay. Second part, you want to show that L composition T is linear transformation. This mapping L composition T. Yeah, for L composition T from here E squared to E squared. You want to show that L composition T of x1 x2 equal minus x2 x1. No, it is a linear one. Next part, for linear one, let you take two vectors x1 x2 y1 y2 belong to E squared. right? Now now you want to show the linear transformation. Therefore you want to take first x1 comma s2 belong to e squared, y1 comma y2 belong to e squared, then right, then uh, mm, L composition T, right? L composition T, S1 comma S2, Y1 comma Y2, right? Y1 comma Y2. Then this one L composition T, X1 plus Y1, S2 plus Y2, right? This value minus X2, this one S2 plus Y2, S1 plus Y1. This value is equal to minus x2 minus y2 x1 plus x2 minus x2 minus y2 x1 plus x2. Okay. Now 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 this L composition T of x1 x2, what is the value? Minus x2 plus x1. Similarly L composition T y1 y2, what is the value? Minus y2 y1. Suppose you add this both L composition T x1 x2 L composition T y1 y2, this one equal minus x2 x1 minus y2 y1. Suppose you get this minus x2 minus y2 x1 plus y1, right? Minus x1 plus y1, but this one equal to this one. No, this one equal to L composition T x1 x2 x1 x2 plus y1 y2. Now addition, okay, two vector addition. Now what scalar, one of the scalar multiplication to the linear transformation. Let we take r belong to one of the scalar number r. Let L composition T of r times x1 x2. Then you can write L composition T of r x1 r x2. This one you get minus r x2 r x1. Then you get r outside minus x2 x1. This one r into L composition T x1 x2. This addition, vector addition and scalar multiplication are satisfying, therefore it is a linear transformation. Therefore L0 T is a linear transformation. Okay, L0 T is a linear transformation. Okay. Here R x2 Rx2 Rx1. L combustion T x1 x2. Here R, here R. The above L combustion T is a linear transformation. Okay. Now you want to find the representation matrix for L, similarly for a T. Then you want to find the representation matrix for the decomposition mapping. First, you want to find the representation matrix for L. Okay. First, you want to you want to find the representation matrix for L. Your function is defined x1, x2, x3, x1 minus x2, x2 minus x3. Here you can use the beta, your order basis beta. Here you can use the natural order basis here 1, 0, 0, 0, 0, 0, 1, 0, 0, 0, 1 for the this natural order basis for the E cube. For a E squared here, for E squared use the natural order basis for R squared 0, 1, 1, 0, 0, 1. Then L of 1, 0, 0 equal x1 1, s2 0, s3 0, 1 0, 1 times 1 0, 0 times 0 1. L of 0 1 0. This question they didn't mention any specific order basis beta and gamma. Therefore, we can use the natural order basis here beta and here gamma. Okay. Here x2 1. x2 1 means minus 1 1. Therefore, minus 1 times 1 0, 1 times 0 1. L of 0 0 1 equal x3 1. Here 0 minus 1. 0 times 1 0 minus 1 times 0 1. Therefore, your representation matrix of L order basis beta gamma equal this matrix. You want to write here column wise 1 0 minus 1 1 0 minus 1. Now you want to find the representation matrix for T. T is defined T of S1 comma S2 x1 s1 plus x2 x2. Now you take for a this one is order basis this one beta dash, you come another beta dash like this. Here also standard order basis 0 1 0 1. gamma, no? Beta 1 0 0 0 1 0 0 0 1. It is for here. Now T of this one for here, no? 1 0. T of 1 0. Here x1 1 1 1 0. This one you can write 1 times 1 0 0, 1 times 0 1 0, 0 times 0 0 1. T times 0 1 x2 1 0 1 1, 0 times 1 0 0, 1 times 0 1 0, 1 times 0 0 1. Therefore now your order basis here gamma beta first 1 1 0, 1 1 0, second 0 1 1, right? 0 1 1, okay? 0 1 1. Now we found the representation matrix for this L and T. Now we want to find the representation matrix for L composition T. Your L composition T mapping L composition T of x1 x2 here minus x2 x1, no? Here also you can take your order basis here e squared, then you can take both the same gamma gamma order basis. Now L composition T of 1 0, S1 1 S2 0. So here also again gamma e squared 0 times 1 0, 1 times 0 1. L composition T 0 1, S2 1 minus 1 0, minus 1 times 1 0, 0 times 0 1. Therefore L composition T here gamma gamma here 0 1 minus 1 0. You both the same order basis, you only put here gamma is enough. Same order basis, no? 0 1. Okay, now right it is your representation matrix. Now they asked to prove that this representation matrix is equal to product of that representation matrix of L and M. Let me check that one. That is one of the theorem, right? One of the theorem that representation matrix, it is one of the representation matrix. It is a product of that two representation matrix. One of the theorem, right? You are going to verify that theorem. Solved. For this T of beta gamma, no? T of you already found. Sorry, not T L, no? Yeah, L of beta gamma into sorry L of beta gamma, yeah, L of beta gamma into T of gamma to beta, then you will get gamma. This you already prove this parts 1 1 0. This part already prove. This two matrix already you prove 0 1 1. Now you multiply this one, you get 1 minus 1 0. They are both were 0. 0 minus 1 0 1 1 0 1 minus 1 0. This equal L composition T of gamma. L composition T of gamma. Okay, L composition T of gamma.